Hi, everyone. This is going to be a video going over section 5.5, which is meant to be a review. So if you recognize this topic already, you might be able to skip ahead or skip this altogether. But if this is not a review for you, if it's been a while or this feels brand new, that's what this video is for, to catch you up so that we're ready to move on to factoring trinomials and some special products when we're back in class together. So we need to start off just learning some basics about factoring, what factoring means, and then some different types of factoring. So to start off, just to give a definition, when we talk about factoring, you're going to hear that word a lot. Factoring means writing as a product. So here's our first fill in the blank. Factoring means writing as a product. So for example, if I were to factor a number like 6, I could write 6 as 3 times 2. Or I could write 6 as 6 times 1. Those are different ways of factoring a whole number. That's not the type of factoring we're going to be doing necessarily. We're going to be seeing factoring of longer expressions that have variables, but that's just some basic examples of what does factoring mean? Writing as a product. So if you're finding a GCF, by the way, GCF stands for, it's down here, greatest common factor. That's what we mean by GCF. To find the GCF of more than one term or a list of terms or monomials, there's going to be a few steps here. We're going to fill those in together. Okay, so first we need to find the GCF of the numerical coefficients, so the numbers. So step 1, find the GCF of the numerical coefficients. We'll see an example of that down below. Step 2, we'll find a GCF of the letters or the variable factors. So step 1, find the GCF of the numbers or the numerical coefficients. Step 2, find the GCF of the variables or the letters. And we'll talk about how to do that momentarily. And then we put it all together. The product, here's our next fill in the blank. The product of the factors found in steps 1 and 2 is the GCF of the monomials. So we have an example of this down below. So we have a list of 3 monomials. We have 10x to the third, y, z to the third. That's our first term or first monomial. Then we have 20x squared, z to the fifth. And then our third one is 45x, z to the third. So to find the GCF of all of those terms, we're first going to look at the numerical coefficients, the numbers. So let's look at the 10 and the 20 and the 45. So sometimes you can kind of just look at a list of numbers and it'll just kind of come to you. You'll see, oh, they all have a 2 in common, or oh, they're all multiples of 3. Or in this case, we might notice 10, 20, and 45 are all multiples of 5. But how would you know that for sure? So there's different strategies for doing this. I like making a factor tree. So off to the side, I'm going to make a factor tree for each of those numbers. So remember, factoring means writing as a product. I'm going to break these numbers down into products, and I'm going to keep going until I reach prime factors, and until I reach factors that are prime, meaning they have nothing, they have no factors, nothing goes into them other than 1 in itself. So for 10, I can break that down into 2 times 5. Both of those numbers are prime. I can't factor 2 anymore or 5 anymore. The only factors of 2 would be 2 and 1. The only factors of 5 would be 5 and 1. So 10 is 2 times 5. Now moving on to 20, I can do 2 times 10. And then the 10 can break down further into 2 times 5. So I'm circling my prime factors there. So you'll already notice some things in common for our 2 factor trees that we have so far. They both have some 2s and 5s in common. And then going to the 45, I can break that down into 5 times 9, and then 9 becomes 3 times 3. With factor trees, there's almost always more than one way to break a number down. So for example, with 20, instead of doing 2 times 10, maybe you chose to do 4 times 5. That's fine. The 4 would break down into the 2 and 2 anyway, so your final result would be the same. So if we look at all of the different factors that we have listed in our factor tree, there's really only one that's common, and that's the 5. So I'm going to circle that. The greatest common factor of these numbers is 5. So the greatest common factor of 10, 20, and 45 is 5. That's the only factor that all 3 numbers have. So that's going to be the first part of our answer, 5. So the GCF of 10, 20, and 45 is 5. Now that brings us to the variables. So to find the GCF of the variable factors, I'm just going to type a note for us. off to the side here, we want to take the smallest exponent of any common variables. Okay, so the smallest exponent of any common variable. So if we look at our three monomials, they do all have x, but if we look at the exponents, we have x to the third, x squared, and then just x. So remember that just x, the one that's just x, that has an exponent of 1. So that really is the smallest exponent. So they don't all have x to the third. They don't all have x squared. They all have at least one factor of x. So we would just say x is the factor of the greatest common factor in terms of the x variables. So again, all three terms do have x, but we want to take the smallest exponent. So that would just be x to the 1. Now the first monomial does have a y, but the others don't. So y is not part of our GCF. And then that brings us to the z. It looks like we have z to the third, z to the fifth, and then another z to the third. So again, taking the smallest exponents, we have 3, 5, and 3. So I guess that would mean 3 would be our smallest exponent. So we would write z to the third. So there's our final answer. That would be our GCF of those three monomials, 5x z to the third. Being able to find the GCF is really important because our next skill that we'll work on is actually factoring out the GCF. So I'm going to scroll down on our notes here. So we just did finding the GCF. We did number 1. Now we're going to go down to number 2 and not only find the GCF, but now factor it out. So we're now on number 2. It says factor out the GCF in the polynomial. So our steps here will be first, find the GCF of all terms, kind of like we did right above. Then we will divide, I'm using quotes here, divide out the GCF and put it outside parentheses. Okay. I'm going to show you what that means now, but I just wanted to write out some general guidelines here. So for our three terms that we have 6x to the fifth minus 8x to the fourth minus 2x to the third. So you can see all of these are even numbers. Our GCF between 6, 8, and 2 would just be 2. Okay, and now if we look at all of our variables, like we practiced right above, we're going to take the smallest exponent from each of those. That would be between x to the fifth, x to the fourth, x to the third. The smallest exponent would be the 3, so x to the third. Okay, so I just found the GCF, but that's not my final answer. I actually need to factor it out. So I'm going to leave some space and rewrite the GCF outside of parentheses. And now we're going to fill in our parentheses by dividing each of those terms by 2x to the third. So I'm going to show that by making these little fractions. Each of the terms is now going to get divided by 2x to the third. Okay, I'm writing a little bit big, but hopefully you can see okay. So I'm first going to start with 6x to the fifth divided by 2x to the third. And whatever I get as my answer, that's the first term that goes in our parentheses. So 6 divided by 2 would be 3. And then based on our exponent rules that we've worked on, when we divide, we're going to subtract exponents. So I will subtract 5 minus 3 and get 2. So my first term would be 3x to the 2, or 3x squared. Now we move to the second term. So this minus 8x to the fourth divided by 2x to the third. So minus 8 divided by 2 would be minus 4. Once again, we subtract exponents. X to the fourth divided by x to the third, we subtract 4 minus 3 is 1. So I just write x to the 1 or just x. So far I've written 3x squared minus 4x in the parentheses. And then finally, when we get to this last term, please be careful. You might notice, oh, those cancel out, right? 2x to the third divided by 2x to the third. I can just cross it out. Yes, kind of, but we're not crossing it out to equal nothing or 0. The reason why we can cross out those terms is because 2x to the third divided by itself is equal to 1. So it's really important that I write minus 1 for my last term. So again, negative 2 or minus 2 divided by 2 would be minus 1 or negative 1. X to the third divided by x to the third. If we subtract those exponents, we would get x to the 0, which we know is equal to 1. So really we get 1 times 1 for that last term. 1x to the 0 is just 1 times 1. That's why it's just minus 1. So our final answer, as we factored out the GCF, is 2x to the third. Well, that was our GCF on the outside of the parentheses. And then in the parentheses, we had 3x squared minus 4x minus 1. You can always check by distributing. So I will make a note of that. So check by distributing. So if you look at the answer we just circled, I could have given you that as a test question in our last unit, right? When we were practicing multiplying polynomials, if we multiply 2x to the third times each of these terms, we should get back to the original. So check by distributing, also known as multiplying. Okay. Great. Okay, now is when I would pause and ask if there are any questions. So maybe you should pause, check your work, make sure you're doing okay. Let me know your questions, and then we'll keep going. All right, so we've made it through the first page. Now we're on to our second page. So there's just 2 pages here for the notes for this section. We're practicing factoring out GCF, and then we'll get into factoring by grouping. So we have one more example on the next page. This is number 3. It says factor out the GCF in the polynomial, but you'll notice it looks a little bit different. There's some parentheses. You might instinctively think, oh, I need to distribute to get rid of the parentheses, but actually no. Weirdly, we will not be distributing here. Keep the parentheses as they are. I want you to think of this pretty long expression as actually just having 2 parts or 2 kind of longer terms. They're not quite terms, but kind of 2 parts, I'll say. So there's 2x times z plus 7 plus 1 times z plus 7. So I just kind of underlined or drew little brackets under those 2 parts. We're going to call those 2 groups. This is going to get us ready for factoring by grouping in the next couple problems after this. So notice what's the same about those 2 groups. Notice what's the same? What looks the same? What do they both have? They both have this parentheses z plus 7. That's our GCF. So we're going to factor out z plus 7. So I'm rewriting z plus 7 in parentheses. If you can picture each of those terms getting divided by z plus 7, this might look a little complicated. We're dividing each of those groups by z plus 7. The z plus 7 cancels. Let's see what's left over. So in our first group, we have the 2x left over, plus in the second group, it again kind of feels like we have, I'm using quotes, nothing left over because we're crossing everything out. But remember, when we cancel out common factors, we are actually left with a 1. So our final answer for this one looks a little bit different. It's 2 binomials. It's 2 sets of parentheses. We have the common factor, the GCF, that I've written in this orange color here, the z plus 7 in parentheses. And then my second set of parentheses is kind of the leftover, parts. So I'm just going to write little labels there. So we have the GCF first, and then my second group, I'm using quotes here. I'm saying the leftover terms go together in our second parentheses. Just like our previous problem, we can check by multiplying. It's a little bit different though. So if I go back and actually distribute in my original problem, I'm going to write that off to the side here. Oops. Okay. So 2x times z plus 7 plus parentheses z plus 7. If I actually did distribute, let's see what we would get. It's going to be kind of long. It would be 2xz plus 2x times 7 would be 14x plus z plus 7. Notice how we get 4 terms. None of them are alike, so we just leave them separate. If we were to FOIL and multiply our 2 binomials in our answer, we will get the same 4 terms. So watch, if I distribute z times 2x, that's 2xz, plus z times 1 is z, plus 7 times 2x, 14x, and then 7 times 1, 7. So it's the same 4 terms. The order is just a little bit different, but it really is the same result, no matter which expression you have. So I've said this before, I don't usually fully check every answer for a factoring problem, but I just want you to know that you can always check by distributing or always check by multiplying. Okay, I'm gonna erase to make, actually I don't need to erase, so never mind, I'm gonna scroll down. So I guess what I want you to know now is if you can factor out a GCF that has parentheses, then now we're ready to move on to a new type of factoring, which is called factoring by grouping. Okay, so we have two examples coming up here. Please notice that both of these examples have 4 terms. So some notes about factoring by grouping. We use this for 4-term polynomials. We're going to be breaking your 4 terms into 2 groups of 2 terms each. Then we'll go from there. So this is our general plan, and then I'll just show you after that. So for factoring by grouping, we use this when we have 4-term polynomials. The way we're going to start is by breaking into 2 groups of 2 terms. Okay, so I'm going to zoom in just so we can have a little bit more focus on number 4 right now. Okay, so here's number 4. It's AB plus 3A plus 2B plus 6. So please notice the 4 terms do not have a GCF. They don't have anything in common with all 4, but if we start breaking up the terms into our groups, then we will be able to factor after that. Okay, so my first group would be AB plus 3A. My second group would be 2B plus 6. So now let's factor the GCF from each group. For our first group, think of it like its own separate problem. It's AB plus 3A. Notice that we have an A in common. So I'm going to factor out an A here. So if we divide each of those terms by A, let's see what would be left. AB divided by A would be just B, plus 3A divided by A would be 3. And just do a quick little check distributing, right? A times B is AB plus A times 3 is 3A. So it works, right? So our GCF was A. We factored out A from our first group and we were left with B plus 3. Now we go to our second group and we do something similar. For our second group, we have 2B plus 6. The GCF here is not A, it's actually 2, right? So we can divide both of these terms by 2. Now, something you might not have expected is instead of just writing 2, it is important that we write a plus sign here. So if you're factoring out a negative, we'll write a minus sign. If we're factoring out a positive, we do need to write a plus when we're doing grouping because we'll need it for a later step. So our GCF for our second group is 2. We'll factor out the 2, and then we're left with, let's see, 2B divided by 2 is B, plus 6 divided by 2 is 3. So you'll notice the colors that I use those for a reason. I want you to see now the B plus 3, that's the common factor. So if I zoom out and just remind you about the problem we had just done, scrolling back up, remember number 3, how we factored out Z plus 7? We're basically able to do the same thing now, only instead of factoring out Z plus 7, we're factoring out B plus 3. It's the parentheses, that's the GCF. So now if we recognize our GCF is that B plus 3, we're going to factor that out, meaning we're going to rewrite it in parentheses, B plus 3. So that's our GCF in parentheses, and then remember how we had our quote leftover terms? That's what's in green right now. That's the A, and then the plus 2 on the outside of the parentheses. That's what's going to make up the second half of our answer. So I'm writing in parentheses A plus 2. And there's our final answer. We just factored by grouping. So we took our 4 terms, we broke them into 2 groups of 2. Each of the groups of 2 had a GCF factored out. So for AB plus 3A, we factored out A and got B plus 3. For 2B plus 6, we factored out 2 and got B plus 3. The B plus 3 is the common factor. That gets factored out, that gets rewritten. So we have B plus 3. And then the leftover terms get their own parentheses, A plus 2. So our final answer, 2 binomials, meaning two parentheses that have 2 terms each, B plus 3, A plus 2. And if you wanted to, you could check by distributing. If you FOIL or if you distribute, you should get the exact same 4 terms that we started with. So B times A, there's AB. b times 2, that would be 2b. 3 times a would be 3a. 3 times 2 would be 6. So it would give you the same 4 terms. They might be out of order, but they're all there. So we would know that we have our correct answer. So that's factoring by grouping. We use it, we attempt to use it when we have 4 terms. We're going to see one more example now. This one is very similar, only what's going to be different is we have some minus signs. So keep in mind, I'm going to type this and then I'll say it. So if your group starts with a negative, factor out a negative. I'm writing it in all caps. Okay, so when we get to our second group for this problem, it starts with that negative 3y plus 2 or minus 3y plus 2. We will need to factor out a negative when we get there. So just keep that in mind. All right, let's look at the whole problem. For number 5, this is 12xy minus 8x minus 3y plus 2. So check to see if there's a GCF with all 4 terms. There is not. So 2 goes into some of those terms, but it doesn't go into 3y. Some of the terms have x, some of the terms have y. 3 goes into 12, but it doesn't go into 8. So there's GCFs kind of mixed around here, but there's nothing that's in common with all 4 of the terms, which is why we're going to go to the next step and we're going to factor by grouping, just like the last problem. So I'm going to separate my 4 terms into 2 groups of 2. And then we'll take out the GCF from each of our groups. So for 12xy minus 8x, 12 and 8 have a 4 in common. So we'll factor out 4. And then both of the terms have x. So we'll factor out 4x from our first term. Now we'll divide each of those terms by 4x. And we should be left with, let's see, 12 divided by 4 is 3. The x divided by x cancels out, but then we still have a y for that first term. So just do a quick check. 4x times 3y, yes, that is 12xy, minus 8x divided by 4x. Be careful, sometimes students write 2x here, but no, the x is canceled out. It's just 2. So we should get 3y minus 2 in our parentheses. Do a quick check again to distribute, see if you would get back to the original. 4x times 3y, 12xy, minus 4x times 2, that would be 8x. So that's our first group. Now we move to the second group. This one's a little bit trickier. It doesn't really feel like they have anything in common. So if you ever run into that, that just means you have a 1 or maybe a negative 1 that you can factor out. So when you look at that second group, minus 3y plus 2, it kind of feels like there's no GCF. I'm just writing a note here. That might mean you can factor out a 1 or a negative 1. There's never going to be no greatest common factor. If you can't find one, or if it feels like there is no GCF, that just means, oh, the GCF, the greatest common factor, is 1, because 1 will go into anything. So I can factor out either a 1 or a negative 1. In this case, because of that minus sign, remember, if your group starts with a negative, factor out a negative. So we're going to be factoring out negative 1. All right, let's do it. So we'll factor out negative 1 from this group. So we're dividing each of these terms by negative 1. Negative 3y divided by negative 1 would be positive 3y. And take a look at how it's starting to match our other parentheses. That's always what we should expect with factoring by grouping. The groups, or excuse me, the parentheses that we end up getting in the second step should be exactly the same. If they're not, if your signs are different or your numbers are different, you need to stop and go back to the previous step and try again, because that's sort of how this is supposed to work. The process is designed so that the parentheses should always be the same. So if they're not, go back and try to identify any errors. Usually it's you missed a negative, or maybe like instead of factoring out a 4, maybe somebody factored out a 2. So you didn't factor out the GCF, the greatest common factor. Maybe you've just factored out a smaller common factor. So those are usually the things that might go wrong. Let's keep going. We're factoring out a negative 1, negative 3y divided by negative 1, 3y, and then 2 divided by negative 1 would be minus 2. And you can see our groups match, our parentheses match. We have in blue here, we have the 3y minus 2. That's our GCF now. So our next step would be rewriting 3y minus 2. And then we have our leftover terms on the outside, 4x minus 1. And if you remember all the way back to the beginning, we did say factoring means writing as a product. So I'll just rewrite that. Factoring means write as a product, also known as multiplication. So that's why we didn't stop in this middle step. We had to stop when we actually had two things being multiplied together. So 3y minus 2 times 4x minus 1. Okay, so we've made it to the end of our notes for section 5.5. All the other factoring that we do will build on this. So it's really important that we understand the concept of GCF, factoring by grouping. And then when we get into factoring trinomials and some other types of factoring coming up, grouping might still be a part of that. So anyway, hopefully this helped. And this was meant to be sort of an at-home, take-home video that you could watch to catch you up with factoring. Let me know what questions you have, and we'll build on this when we move on to our next section, factoring trinomials, and then we'll get into some special factoring formulas as well. Okay, thank you very much.